So friends, in this session we are going to learn about how to read the schematic diagrams of the new generation laptops. So here I have one a schematic diagrams of the Inventec board. So this is a Inventec, because nowadays this Inventec boards are very common in HP laptops and the Dell laptops, and the Inventec's number normally start from 6050. See, if it is a Compal motherboard, the numbers start from LA, and if it's a Wistron motherboard, then the numbers start the 5 digits, and if it is a Quanta, then the numbers start from the DA. But nowadays, the latest generation, most of the motherboards are the Inventec motherboards, and their numbers start from 6050. So I have this board which is a 6050A30225001-MB-A01. Okay, so this is my motherboard number, and this is a 2019 model. And so this is a table of content. That means this diagram is a total 105 pages, and this is the index page, and this is the block diagram. Page number 3 is a block diagram. So this is a CPU, Whiskey Lake CPU. Okay, and these are the component connected, and this motherboard have the two power inputs, that is type C input also, and the adapter also. That means normally we see in older laptops, and all the older laptops, the power they receive from this adapter, and that is called the DC jack. Okay, and this new laptops coming with the type C power inputs, but this laptops have the two power inputs, that is you can connect either adapter or from the type C ports. So power, he take the power from the both the side, either adapter or from the type C port. Okay, so I'm going to explain how the things are work, and how you are to how you can trace the power in this types of motherboard. So first we start from this DC jack. So we'll go to the DC jack, and we'll see the how the power goes in. So this is a page number 3, and this page number 4 is a clock, and these are the power this thing inputs. Okay, we'll scroll down, and we'll go to the page number. Okay, so this is my adapter page. So page number is 29, and here is my adapter inputs. So this is my adapter inputs called the DC jack, and from the DC jack here is mentioned the VCC, that means the supply. My 19 volt will come from here, it will come here, and then it cross this two coil. Okay, and here's the names again. So what we have to do is, we have to select this signal, and the signal will tell this where is the connectivity. Okay, so we are here in this page number 29, adapter inputs, and then it's called the PV ADP DC. Okay, once we connect the adapter, here's the 19 volt cross this two coil, and then it will come here across this capacitor, and this voltage name will become the PV ADP. So we'll here type on the find PVADP, and we'll press on next, then next, and then next, then these are the capacitor. Will keep on continuing to next, and here, yeah, you can see here, at page number 7, this PVADP. Okay, so my voltage is coming here, so my adapter voltage will come here. Okay, and then he crossed this MOSFET. This MOSFET is Q60010. Okay, and then my 19 volt will come here. Okay, it's called a VADPBL. Okay, this voltage will come here. So what I have to do is, I have to see where this voltage is going. So this VADBPL. So what I do, I have to select this, then I will select this signal and delete this. I will select this signal, I'll copy it, select, then copy, come here at find, put the value, paste, then click on the next. Though my adapter voltage is coming from this side, it's coming here, cross this Q60010, then click the next, and you can see my voltage is coming here at this Q6800. Okay, so here, so this is basically a junction. Okay, so you can see here, so this is basically a junction. So this is a Q6800 MOSFET. Okay, and you can see this voltage is coming from, this is voltage is coming from the adapter, and from here the voltage is coming from a type C port. The voltage is coming either from here or from here. Okay, if you connect the adapter, then voltage will come here, and then this voltage cross this MOSFET. This is the MOSFET location is Q6800. We are here in the page number 8, that this 19 volt will cross this MOSFET, and this is here the system voltage will be generated. So what you have to do is you have to check the voltage over here. Okay, so the 19 volt, you have to check here the 19 volt or 19 point whatever is, but mostly 19 volt will be here. So you have to check this 19 volt at this junction point. So this is your junction point, so you have to check this voltage here. Okay, if you are connected to the adapter or from the type C also, both anywhere. So this is basically a junction. The next is when the voltage is coming here properly, then this voltage is going to the buck boost converter. So what we'll do is we'll select this signal, copy this signal, cancel the prehistory data, paste here, click the next, next, then next. You can see now bring me on the page number 7, where here is a buck boost converter. So you know that how the buck boost converter work. If you don't know about the how to buck boost converter work, then you can watch our buck boost converter video, how the things work in buck boost. Buck boost converter is basically, buck converter is basically the reducing the voltage, and boost converter means basically boosting the voltage. So this circuit is reduce the voltage also, simultaneously can increase the voltage. If the power is coming from this side, okay, then it's a buck converter, and if the power coming from this side, then the boost converter. Now my 19 volt will come here at this point, cross this current sensing. So this is my current sensing resistor, cross this current sensing resistor, and here are the two MOSFET, the control by this chips. So the chips location is, can come here and see this intercell ISL 9241 chips. Okay, and this chips get a power at is a VDD pin number 18, then DC in here get a 19 volt here, and of course AC detect signal will be there. It detect all the AC detect signal, then AC OK out signal, and then he started switching this two MOSFET. Here are the two MOSFET. Pulsating AC voltage will be generated, and here is a coil, and then pulsating AC voltage cross this coil, and then this switch, this chips trigger this particular MOSFET from here, and then here the output voltage will be generated. This output voltage is supposed to be a 13 volt. Okay, so this is my output voltage. Now you can see voltage is coming from 19 volt is coming from this side, and this buck boost converter switch reduce the voltage and will get here the output voltage. This output voltage is depend, of course, model to model. Some in model is 13.05, in some model is a 11.1 voltage, depend model to model, but we can assume here as a 13 volt. So you can get a 13 volt over here at this capacitor, and this is your our system voltage. Okay, and this voltage is coming here, and then this voltage is called the PV band. Okay, so PV band, and this voltage is going to the different buck converter. It is going to the 3.3 volt section, it's going to the 5 volt section, it's going to the RAM. Suppose the DDR4, then is 1.2 voltage, then the CPU core, then the PCH voltage, then the graphics code voltage, and even the backlight. So this is the output voltage. So what you have to do is you have to go simply checking this signal one after another, and this will output. And if the voltage is not coming, if the 13 voltage is not coming over here, then you have to see why this voltage is not coming. So that you have to go back and you have to check here 19 volt. And if it is a 19 volt is okay, then the previous sections are okay. And still, and if the 19 volt is not coming here, then you have to go back and you have to check the signal. And if it is a 19 volt is coming here, but the 13 volt is not coming here, then you have to see the circuit, you have to check this chips, you have to check the DC in signal, you have to check the AC in signal, you have to check this output signal triggering this two MOSFET, you have to check this MOSFET and this MOSFET, like that. Okay, so in this way this circuit work from the adapter. And this is the battery side. So this is a PV pack, is a battery output. Okay, so here is a two output. One is going to the system voltage, and this is for the battery. Once battery need a charge, at that time this VR gate is trigger this MOSFET, and then the same voltage, the 13 volt, will come here, cross this current sensing resistor, then cross this MOSFET and entered into the battery, and the battery started charging. Okay, so in this way it's work. Now what will happen if there is a no adapter? In that case, the battery voltage will come from this MOSFET only. When the adapter is not present and the laptop need a charge, at that time, what will happen? This PV back, the battery output voltage, will come cross this MOSFET, because in this MOSFET there is a, you can see there is a diode. So the voltage travel from this MOSFET bidirectional. When the battery need a charge, the power go from this side, and when the system need a charge and voltage coming out from the battery, then voltage coming from this side. So this is basically a dual MOSFET. When battery charging, the power is going from this side, and from the battery voltage is going to the system, then voltage coming from this side. Okay, so now if the adapter is not present and the system work on the battery, then the battery voltage cross this MOSFET, come here, this current sensing resistor, and then voltage will come out here, goes here, goes here, and from here pad it will go to the PV band output. So this is a system like that. So in this way these things work when we connect power to the adapter. So now we'll see how things will work when we connect to the type C adapter. So because this laptop have two power inputs, and we can see here is my type C connector. So this is my type C connector, and in this type C connector we can see, in this type C connector we can see there is one signal is called the V bus. Okay, so this is a V bus. There are in type C port there are multiple signal like CC, then SBU, then TX, then RX, D plus, D minus. These are so many signals are there. If you're not aware about the type C signal, then you can watch my another video about type C ports. Okay, so here we are not going to discuss about the type C ports, so you can watch the another video, there it's explained in details. So now we'll come to the point is that when we connect the adapter, the type C adapter at this port, then from the V bus the 20 volt come out. Okay, so from V bus the 20 volt come out, it's called the PV V bus underscore CTR. Okay, so this voltage and the voltage is supposed to be 20 volt. Okay, and then this signal, this voltage is going to the next MOSFET. So we'll see where this voltage is going. For that, what we'll do, we'll select this voltage name, we'll copy this, we'll come here, click on the find, remove the signal, select on the paste, then next, then next, and then next, then next, and you can see the power is coming on page number 58. Okay, so page number 58, and we can see there is a voltage path. My type C voltage, that is a 20 volt, is coming from here, and the type C controller chips trigger this MOSFET because there is a CC line. The configuration channel CC line detect the voltage, and the type C controller chips drive this MOSFET, and then this 20 volt cross this Q2609 MOSFET, cross this 2609 MOSFET, and the 20 volt come here output to the drain, is entered into the source and come out from the drain, and then that signal name get changed. That signal name is now VCC underscore HV underscore sys. So what we'll do, we'll select this signal now, and now we'll select this signal, copy, cancel this, and paste here. Then the next is okay, next. So you can see now, you can see we come at the page number 8 where we was. So here the power is coming from this type C port. It's called a VCC underscore HV underscore sys, and there is a MOSFET is called a Q8101. Okay, now you can see this power is coming from this coming here from this uh, adapters, and the power coming from, here is a type C port, here is a 20 volt will come, and then this 20 volt will cross this MOSFET, come across here, and that voltage is called a PV system. Okay, it comes the PV system, and then this voltage is going again to the buck boost converter. So friend, in this way this power concepts work. So suppose if your laptop is dead, if it is not powering on, then what you have to check, what you have to do is you have to see why this, where the power is stuck. You connect the adapter and check all the signal and the voltages which I told you, and if the power is not coming from the type C adapter, then you have to check accordingly, explain in this video. Okay, I hope you understand this concept. Okay, if any doubts you can contact me. So thank you very much.